Alright, this problem here, number 6, you're supposed to start out with a fact, manipulate it so you can end up with what it says here for number 6. And this problem is going to take longer than you care to hear. I notice in this problem there's b's and there's c's, so I'm going to start out with sine of b over b equals sine of c over c. Then I am going to multiply both sides by b. What I'm trying to accomplish right now, I'm trying to get all my small letters together and all of my big letters together, because you can see in what you're trying to prove, small letters are together, big letters are together. That's what I'm trying to accomplish right now. So now I got my little b and c together. I'm going to then divide both sides by sine of c to get rid of, right now I'm multiplying the right side by sine of c. I divide both sides by sine of c. On the left, I get sine of b over sine of c. On the right, I get b over c. So we're cooking with gas now. If we continue, notice what we're trying to prove has addition in it and subtraction. Let's just focus on one of those. Let's focus on addition. Let's add 1 to both sides of the equation. One can take many forms. That's why I chose to add 1 to both sides. To add 1 to a fraction, you need common denominators. So on the left, that denominator is sine of c. On the right, that denominator is c. When you add two fractions, you add the numerators, you leave the denominators, the bottom, you leave those unchanged. So we're getting closer I should say. Now I'm going to do something that is counterintuitive. This is probably not going to make much sense while I'm doing it. But I can't take this problem much further and try to get subtraction in it. At least there's no way that I've thought of. So what I'm going to do next, I'm going to backtrack a little bit since I got this addition in here. I'm going to solve the equation so I have sine of c over c by itself. So to do that, I'm going to multiply both sides by sine of c, and multiply both sides by this right here. On the left, your sine of c's cancel. So you get sine of b plus sine of c. On the right, since you're multiplying by sine of c, you get sine of c times b plus c over c. Multiplied both sides by sine of c there. Then I want to get my b plus c on the left. Right now it's being multiplied. The opposite of multiplying is dividing. So if I divide both sides by b plus c, I get this. Now, I'm going to stop right now, and I'm going to restart this problem. Don't forget this. I'm going to erase it. This is important. So we're going to come back and we're going to use that again later. So to restart this problem, I'm going to erase this. Don't erase what you have. I'm just going to be doing a similar thing. In fact, I'm just going to cheat a little bit. That's how I was raised. You would rewrite everything you see here on the screen, but instead of these pluses, let's make them minuses. You just redo the entire thing that you just did. If you redo the entire thing that you just did, instead of adding 1 to both sides, you subtract 1. You might want to pause this video to give yourself time to write all that down. So what ends up happening is we end up with, from the first time that we did this, sine of b plus sine of c. And I missed this right here, it's supposed to be minus as well. Over b plus c is equal to sine of c over c. And then the second time we did it, we got the same thing on the right, but on the left we have minuses instead of pluses. What that means for us is we can set these two things equal to each other. That's a transitive property. If two different things are equal to the same thing, then those two things are equal to each other. So I'm going to set them equal to each other, and I'm going to try to manipulate that to get what we were trying to prove, what we can see here on the left, top left of your screen. So from that, we can say sine of b minus sine of c divided by b minus c is equal to sine of b plus sine of c over b plus c. Looking at what we are trying to prove once again, you can see all the necessary parts are there. They're just wrong in the wrong order. Things that are in the correct spot. This is already in the right spot. It's on the top right fraction. This is already in the correct spot. It's on the bottom left fraction. Those things need to stay put. What we need to move, this b plus c, we need to move this. Right now it's the bottom of a fraction, we're dividing by it. So the opposite of dividing by it would be to multiply. So let's multiply both sides by b plus c. If you do it on the left, you get the following. If you do it on the right, the b plus c's cancel. Now if we look at what we're trying to accomplish, we got three things in the right position. B plus c is the top left, b minus c is bottom left, sine of b plus sine of c is on the right. The only thing that's wrong is the sine of b minus sine of c. It's being multiplied on the left side. The opposite of multiplying is dividing. So we're going to divide both sides by sine of b plus sine of c. If we do that, on the left we get b plus c over b minus c. On the right, we get sine of b plus sine of c divided by, we divided both sides by sine of b minus sine of c. At this point, we have the exact same thing that we were trying to prove, which means that we are finished and we have proved it correctly.